Hello, Astronomy. Welcome to our second lecture video for Unit 1. So I want to begin here with what is possibly the most perplexing astronomical mystery of all time, one of the issues in the sky that perplexed ancient peoples for millennia, something you've probably never heard of, never noticed, never even knew about, but is one of the most consequential things in the history of astronomy. And that is the issue of what is called retrograde motion, okay? So retrograde motion. So this is a picture taken of Mars, right? And this is a picture of Mars from, you can look at the dates, August 23rd, 2007 to April 28th, 2008. So over a course of about a year. Now, something about the motion of Mars in the sky. So if you go out tonight, assuming Mars is in the sky, you will see, say you go outside and look at midnight, you will see that Mars is in the sky, right? It is in a constellation. Maybe tonight, Mars is in the constellation Aquarius, all right? Aquarius rises, Aquarius sets over the course of the night, and Mars is fixed in that constellation, all right? Now, if you go outside the next day or in a week or in a month, you'll see that Mars is in a different constellation, all right? For that night, it's in the same constellation. It doesn't seem to move through the constellation. But if you go out at the same time, say midnight, every night for, in this case, about a year, you'll see that Mars wanders through the sky, all right? The word planet is actually a Greek word that means wanderer, because planets, unlike the stars, are not fixed in the sky. Planets can wander from one constellation to another, again, because they're planets and they're not stars, all right? So what you can see in this picture, though, is that over the course of about a year, not only does Mars move between constellations, but at some point, right about here, it seems to loop backwards and then stops in its motion and goes back in the direction it was originally. So Mars, from night to night, makes a loop-de-loop in the sky over the course of a year or more, okay? This is called retrograde motion. And this is a tough nut to crack because, to the ancients and even, medieval people, Mars circled around the Earth. Earth was the center of the cosmos, right? And if that's what's going on here, then in Mars's orbit, there's times when it goes back where it came from. And, this is something difficult to explain because, that just doesn't seem like it's possible, right? Now, we know today that what's going on is Earth is not the center of the solar system, the sun is. And, Earth is planet 3, Mars is planet 4. So Earth's orbit is closer to the sun. So Earth can lap Mars in its orbit, right? And in a minute, I'll show you a little animation that explains what's going on here. But the reason why we get retrograde motion is because when, if Earth catches up to Mars and passes it, then it basically means it's sort of like an optical illusion of sorts, that Mars seems to, from a period of nights onward, go back in a position in a constellation and then go forwards again, all right? But retrograde motion. So Ptolemy, we've probably discussed Ptolemy before, at least briefly. If we haven't, let's introduce him. Ptolemy was an ancient Greek scientist, very, very, very famous. Ptolemy's writings, were lost for a time, then they were rediscovered during the Renaissance and translated. Although, to be fair, the Arabic scientists had Ptolemy's writings, so it was only lost to Europe, I should say. And Ptolemy solved retrograde motion by using what are called epicycles. Now, let me be clear, this model is wrong. This model is not correct, but it's a very sophisticated model, and it actually works to accurately predict where Mars will be, 30 years ago, or where it will be tomorrow night, or 30 years from now. So basically, here's Earth. The big blue circle would be Mars's orbit, but within Mars's orbit, well, in this case, this could be any planet, not just Mars. All the planets can do retrograde motion. Within the orbit of, say, Mars, the planet has a thing called an epicycle where it sort of moves in a circle in its orbit, right? So say this circle is moving to the left here. If the planet is doing this part of the circle, then for a period of time, even though its overall motion in the orbit is going to the left, it appears to be going to the right because it's in like the back half of the loop-de-loop. And if you look at this diagram in Ptolemy's Epicycle model, you can see like what the planet actually does is does a little loop-de-loop, because when it's in this part, overall the orbit's moving to the left, but it's briefly moving to the right because it's in this part of the epicycle, okay? So this is Ptolemy's model. This would be a Ptolemaic model of the solar system. So there's lots of things wrong with this model. Obviously, Earth isn't the center. You have Mercury, then Venus, then the Sun, then Mars, Jupiter, Saturn, then the fixed stars. It doesn't have Uranus or Neptune because those weren't known in ancient times. The moon doesn't have an epicycle because the moon actually does go around the Earth, so the moon doesn't need epicycles. But the other planets do. The sun doesn't because it doesn't do epicycles. The sun, of course, we know is the center of the solar system, not the Earth, or things rotate or things revolve around the sun, I should say, not the Earth. So this is the Ptolemaic model, and if you notice, I mean, it's complicated. All these planets have epicycles. It's a complicated model. A rule of thumb: the more complicated something is, like a model that's simpler is probably more likely being correct than one that has more working parts. The simplest explanation to something is usually the one that's correct. So this picture, so like I said, ancient Arabic scientists had Ptolemy's works and translated it. This is a drawing in one of their works of the Ptolemaic model, and I put this picture here. This is a very important picture to me because one, it shows Ptolemy's model of, I'm not sure what the script means or what these letters mean, but I'm assuming like here's the Earth, here's the planets orbit around the Earth, and here's the epicycle. You can see it, but it looks like there's trig in here. And even though Ptolemy's model was wrong, it was taught and refined and passed on for thousands of years, but it worked. It accurately predicted where Mars would be tomorrow night, or a year from now, or a century from now. And of course, we've discussed before how, especially in the Middle Ages, it was sort of trendy to have your charts read, to have an astronomer like tell you where Mars was on the day of your birth. So being able to not only predict the location of planets in the future, but also like where they were years ago was like a trendy thing to do. Even though today we would call that astrology, right? It still led to some accurate astronomy. So my point I'm making here is, even though this model was wrong, it was very, 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 very accurate. It worked. And so until another model comes along, say the sun-centered model, that is a simpler model. In the sun-centered model, you can drop epicycles. You can explain retrograde motion just using the motion of the planets around the sun. And like I say, the simpler the model, usually the more likelihood of it being correct, as long as it accurately predicts things. But we sort of, in our modern society, we have a tendency to like look down on ancient peoples or think that we're smarter than they are. When look at this picture. This person could do a lot more math than most people can do today, and their models might not be correct, but they're very good at predicting things. I mean, most people today couldn't find, on my phone, I have the Skyview app where I can locate things in the sky with my phone. Without my phone, when it comes to looking at things in the sky, I'm trash. I can't find anything besides like the moon and maybe some of the brightest stars and constellations. Ancient peoples were way better at astronomy in terms of finding things in the sky than I am, or that most anyone is today, because they had less to work with in terms of like, I have a phone. They actually had models that could figure things out. That again, even though they're not accurate as to what we know today, they're very good at predicting things. And they, if you have to work out a model that's so complicated that it's correct, even though if it's wrong, that probably means the problem very, very well. Even though your solution is wrong, you still know it better than say most people do today. There's an argument that ancient peoples actually, in terms of using their brains, were further along the intelligence scale than we are today, because we rely upon technology so much, like a phone, that ancient peoples didn't have. The argument that a caveman used more of his or her brain to survive than we do, because they actually have to encounter different scenarios more scenarios than we do today. Anyway, that's a bit of a tangent, but you know, I think retrograde motion is a great example of ancient peoples figuring things out in astronomy. Okay, so this video, this is a little sort of like animation that explains retrograde motion. This is like 4 minutes. I want to show it. I'll be honest, my brain isn't a very visual brain. I have a hard time picturing things in my head, and I think this is useful to visualize what's going on. So I'm just gonna let this play. I'm gonna be quiet. Okay, so I think you get the idea now. So again, retrograde motion was that thorny problem that solving it required us to change what the center of the solar system was, or what things revolved around from the Earth to the sun. Okay, so switching topics now. So the reading mentioned this earlier. So a handy way to measure distance or to measure space in the sky. So these are degrees, as in degrees of like area. Sometimes if you're looking for things in the sky, you'll see something described as being like 10 degrees from the moon or whatever. So your pinky is about 1 degree, 3 fingers is about 5 degrees, a fist is about 10 degrees, 15 degrees is about like that symbol, and 25 would be pinky to thumb furthest out. All right, just a good handy way to measure distances, or not distances, but spatial distances, like degrees in the sky. So this is a pretty trash picture, to be honest, but this shows the point that I made in a previous video about how most things in the solar system being in a single plane. The scale here is terrible. The sun's way bigger than the planets here. The orbits, the outer planets are way further away. The scale here is complete trash. But this just goes to show, if you look at the planes of the orbits, they're more or less in the same plane. You don't get things like way above the sun or way below the sun in terms of planets. Comets and such, they can come from anywhere, but the planets are more or less in a flat plane. And a plane can be take like the orbit of Jupiter and make it like that just a little. The plane of the orbit can be 1, 2, 3, 4 degrees above or below the plane of the solar system, but more or less things are in a flat plane. And the application of that, or the result of that, I should say, is what we have that we call the ecliptic. I mentioned this in the previous video. The ecliptic is like an imaginary arc in the sky that is the plane of the solar system, right? So all the planets and the moon are in the ecliptic, right? This picture just shows like the full arc in the sky. In this picture, you can see the moon, you can see Mars, Venus. The sun would be in the ecliptic. Of course, this is nighttime, so you're not seeing the sun. But planets, moons, and the sun all move through the sky in the ecliptic, all right? I also mentioned in the first video briefly how the significance of the constellations of the Zodiac is because those constellations are actually in the ecliptic. So here you see the Virgo. Virgo is a constellation that's in the ecliptic. Now, stars, let me go back a second. Stars, no, actually, hold that thought. Stars can be anywhere. Stars can be above Earth's North Pole, below, whatever. I mean, you can see stars over here that are not in the ecliptic, but the 12 zodiacal constellations are the ones that happen to be in the ecliptic. So if you took Earth's plane, or solar system, and expanded it out into cosmos, the stars it would hit would be ones on the ecliptic, okay? This shows the ecliptic of like the entire night sky. Of course, you never see it like this because you can't see them all at once. But Taurus, Aries, Pisces, Aquarius, you can read them. They're the zodiacal constellations, so the sun can be in a constellation, as can the planets be in a constellation. Ophiuchus, this one we're going to talk about in a minute. It's not officially one of the 12, but it should be. We'll get to that in just a minute. Okay, so like notice Orion, not on the ecliptic. Orion's not a constellation in the zodiac. Ursa Major or Ursa Minor, some very famous constellations that aren't on the ecliptic because they're not on the ecliptic, so they're not part of the zodiac. The ones of the zodiac are the ones that are on the ecliptic. Okay. So this picture, I picked this picture because sometimes it gets a hard time understanding what it means to be in a constellation. So say you're on the Earth here, you're facing the sun, so it would be daytime. The background of the sun would be in this constellation, which is Pisces, right? A diagram like this is a similar diagram. Like the sun isn't actually inside the constellation, but in terms of the background of the stars, think of that as area. You can be within that constellation's area. So if it's February 21st, just let's do some examples, and you're here and you're looking at the sun, which don't do directly, but say it's daytime. The sun is in the constellation Aquarius, see? 6 months later, Earth is here, say it's August 21st, you're looking at the sun is in constellation Leo, okay? So you can divide a year, the sun going, or the Earth going around the sun takes a year, into 12 phases or 12 months. So we divide the year into the 12 constellations of the zodiac. Now, some problems. Number one, what if the sun's right here, right? If the sun's right here on August I don't know, 28th, which constellation is it in? It's between them. Well, you kind of have to decide. Like if it isn't actually within the boundaries of the constellation, you just decide, well, if it's here, I don't know, your Pisces, Aquarius, I don't know where you would be with whatever the signs are for August 28th, which actually those are wrong. We'll get to those in a minute. But the point here is you can use the zodiac kind of like a calendar, and you divide the year into 12 increments into the 12 signs of the zodiac, okay? And of course, you know, December 21st to June 21st, that's 6 months apart. So Gemini is 6 months from Sagittarius. Okay, so the zodiac, you know, we think of it as astrology, which is trash, true, but the astronomy behind why things are where they are is not trash. And understanding the zodiac, you know, the tools that you need to predict or to know where the sun is, you know, you might be doing astrology for, you know, to get paid to do someone's charts, but you're doing astronomy to actually do it, okay? So even though astrology is not science, you have to do science in order to do astrology. Does that make sense? Okay. Okay, now, so big problem, okay? You've been lied to for your whole life. So precession, if you've ever spun a top, like the little toy or like a little gyroscope, those little toys you get, and, you know, Earth rotates on an axis, right? And a top or a gyroscope spins on an axis. Precession is the phenomenon where the axis like moves in a circle. How you might use the word wobble, how the axis seems to wobble. Hopefully you've spun tops before. And let's be clear about this. Like the top is still tilted. The gyroscope is still tilted. Like as this thing moves in its precession, it's not like the top is ever go straight up and down. It's spinning and it's wobbling. So it's always tilted, but where the tilt is pointed to changes. If you look at a diagram of the Earth is always tilted 23.5 degrees. You probably learned this in middle school, like Earth is always tilted, but Earth wobbles on its axis, all right? It's not like the Earth's tilt changes, but picture the Earth, you know, rotating along an axis like this, you know, rotating, but the axis itself is doing this number, all right? Some kids get this confused. The axis is always tilted 23.5 degrees, but the circle that it makes in the sky, or it formed where the where the North Pole of the Earth is pointing toward, makes a circle in the sky. Okay. Now we know that the North Pole points to Polaris. That's because it's the North Star, right? Well, if you have precession and Earth's axis wobbles, that the North Star changes over the course of history, which guess what? It has, all right? The North Star hasn't always been Polaris. You can look at this diagram. 3000 BC was the star Thuban, which when the pyramids of Egypt were built, you know, you read in the reading how some of them have shafts of light shafts of light that point to places in the sky. One of them points to nothing, but if you go back to 3000 BC, it would have pointed to Thuban, which would have been the North Star at the time. 14,000 AD, so in 12,000 years or so, the North Star will be Vega, okay? So, you know, the Polaris, you know, there could not be a North Star at all. The North Pole could point toward nothing in the sky, but it happens to point toward Polaris, which is the pole star. Well, that changes, okay? Precession is a phenomenon. The ancient peoples knew about precession. This wasn't something we discovered. The ancients knew that the North Star changed because Earth's axis wobbles. They weren't quite sure. Well, they didn't understand the Earth was rotating, so they didn't have the reason for why it changes. They didn't have that part, right? But they knew that it changed. So because of precession and because where the North Pole points changes, like this number, the signs of the zodiac are all wrong, all right? You know, the idea here is, like if you look at the original dates, which the original dates are the ones we still use, like in newspapers, even though they're wrong. So Aries would be March 21st to April 19th. That would mean that from on those nights, the sun, or during the daytime, because it's the sun, is in Aries, right? Well, it's actually not, all right? The sun's actually in Aries from April 18th to May 13th, all right? So the original dates, if you look at them, there's 12 because we want to divide the sky into 12 regions, right? And the times are about a month. If you look at the corrected dates, Look at Aquarius, that's less than a month. Pisces is more than a month. Aries is less than a month. And we have to add one called Ophiuchus. Ophiuchus is very short, it's only 19 or so days. You know, look at Sagittarius, it's more than a month. These dates are the actual dates of when the sun is in each constellation. But in terms of doing astrology, people don't correct it. They still use the original dates, which is another reason why astrology is bunk, because it's not even where the sun actually is. But the reason why you have to correct the dates is because of precession. And the dates were first picked, you know, when they were first written about in ancient times, it was correct, right? Of course, they'd have to pick, if you're between, you know, if you're between Pisces and, I don't know, Aquarius, you got to decide which one you're in. The dates were correct, you know, 2,000 years ago or whenever they were picked, but today they're incorrect because of precession. You know, my birthday is March the 4th, so I am a Pisces, right? But in actuality, on March the 4th, the sun is in Aquarius, so I'm really in Aquarius. Although anyone would say that my sign was Pisces. Anyway, you should understand the reason for having to correct the dates as being precession. All right, we're going to end there. Hope that was useful, and I will see you guys next time.